Okay, exponential graphs. When people talk about exponential growth, they use bandy that term around willy-nilly in a way that's probably totally meaningless to most people. When people talk about exponential growth, they mean, oh, it just shoots up. But exponential really depends on what your exponent is, or what your base is. An exponential graph, as you see, they do tend to shoot up a little bit. And what it is, the formula is y times a to the x. Or if you weren't writing it in a computer, we would go y a to the x. So that's why it always cuts through y, through 1, because y equals a to the 1 equals 1. Hang on, this is 0, sorry. Because when x equals 0, the answer will always be 1. So these graphs always cut through 1, unless we're adding something on, but we're not. So this one here, it cuts through a 3 as well, so it's y equals 3 to the x. This one is y equals 2 to the x. This is y equals, as I say there, 1.2 to the x. So you can see the bigger the number is, the faster it goes up. And that's because it means that each time we're multiplying by 3 or multiplying by 2, so for every 1 we go across here, can you just stop talking? You multiply by that number again. So exponential means that each time you go up by 1 on the base, you're multiplying as you go up. When we did those linear graphs, every time we went along 1 along the base, we added. Exponential means we multiply, and that's why it is useful in finance, because this is what happens with compound interest, which is the topic of our next module. So say you deposit $5,000 at 6% interest compounding annually, what does the amount do over 25 years? So let x be the year, so we've got along here, we've got our year, and we're going to multiply each time, we've got our amount, and we're going to add on 6% interest. So we're multiplying by 1.06, which you remember from Module 1. So you see here, this is not a straight line, it is a curvy line. And that is why you guys need to get into KiwiSaver or something like it as fast as possible, because at the beginning it doesn't go up much, but the longer you have, the more you are going to gain at the end. It's really, I'll be showing this in terms of financial mathematics as well, is that if you get put even a small amount in as a regular amount with compounding interest can be your friend rather than your enemy, as it is on hire purchase. So here we've got, what about 8% interest? So here we've got 6% interest, you can see it goes up like that. 8% interest, it goes up an awful lot more. And that is why people with mortgages get really jittery when the rates go up, but people who have savings get very excited because their savings are gaining a lot faster. So these are both exponential graphs. Right. I know I've romped through that, but you actually don't have to know it very well. It's just basically to recognise these shapes is what I want from you.